Hi, this is Dima Brook, CTO of XP.network, and today we're going to talk about what it means to bridge EVM and non-EVM blockchains. The first thing we have to talk about is what is a blockchain. As we know, blockchain consists of a network of computers where all the computations happen. And the computers act as peers. It means they see each other. And the program that runs on the computers is called a node. So this is a network of nodes. Let's look inside one of the nodes and see what happens there. Every node produces blocks, and the blocks are connected. Therefore, we can speak about a chain of blocks or a blockchain. Every block is numbered. The first number is 0. Therefore, the last number, the number of the current block, is n-1, where n is the number of blocks. The next question is, how are the blocks connected? Well, first of all, what is a block? A block is a group of transactions. Transactions are numbered from 0 till, again, n-1. It also consists of a hash sum of the block itself. It means all the information inside the block is turned into a hash to identify the block. And it consists of a nonce, which is a number used only once to produce the difficulty required by the blockchain for this block. So as we can see, the first block is numbered 0. This is the Genesis block. And every next block is connected to the previous block by the hash sum of that block included into the next block. And this effectively creates a chain. So the blocks are connected to each other via the hash sums of the previous blocks. And this makes the blockchain immutable, because if you change even one digit inside one transaction, it will change the hash sum for the entire block, and it will not match with the previous blocks. This is how the blockchain is protected from hackers. The first blockchain that we know was called Bitcoin. Again, Bitcoin was a distributed ledger. What is a distributed ledger? It's like an accountant's book that keeps record of the assets and their owners. And it's distributed because there is no one computer that controls the entire database of those records. But there's a network of computers, and there is no one center. Every computer is a center. Every computer is connected to all the rest of the computers. And this creates a network effect where you can't destroy the blockchain unless you stop all the computers that comprise this blockchain, which makes this blockchain unstoppable. As we know, Bitcoin became public in 2009 by a group of developers. Called themselves Satoshi Nakamoto. As people started interacting with Bitcoin and its tokens, they figured out that there's a fundamental problem connected with this blockchain. And the fundamental problem is that once you launch the blockchain, you can't stop it. And therefore, it's impossible to upgrade it and add some additional logic to this blockchain. And this gave birth to another blockchain, which we know as Ethereum. So it's also a distributed ledger, but it already had some differences. And the major difference was that Ethereum allowed for upgradable logic. And this upgradable logic came in the form of smart contracts. Smart contracts are pieces of code that once they're written and deployed on the blockchain, they become immutable. It means you can't change the code of this contract anymore. And this allows people to use this contract without trust, meaning they can read the code of the contract and they don't need a third party that they need to trust, for example, a bank or a government, to make sure that all the parties behave honestly. Smart contract acts like a state machine. It has inputs and it produces outputs. The outputs are recorded on the blockchain database. And there are certain rules written in this smart contract. The rules regulate how the changes are made and how they change the state of the smart contract. This was the major novelty introduced in 2015 by the team that stood behind Ethereum. What is a virtual machine? So today we're speaking about EVM, which is Ethereum virtual machine. So let's speak about what a virtual machine is. A virtual machine concept was long known before blockchain industry appeared. For example, developers used virtual machines to test software on different operating systems inside one computer. Instead of buying multiple computers and testing their software on multiple machines, they just installed virtual machines. For example, you can install Windows inside Mac and test the application that you wrote for Mac to see how it will behave in Windows. So effectively, it creates a simulation of multiple machines inside one machine. So this is what a virtual machine is. It's a runtime environment where some logic can execute according to the rules of this environment. So Ethereum virtual machine is also a kind of a runtime environment that can run on the Ethereum blockchain. It consists of several fundamental components. The first component is a stack. It's like a pile of plates. Usually, imagine a pile of plates. The plates are very heavy. And once you build this pile, it's very inconvenient to take a plate from the bottom because the plates on the top are very heavy. So you would prefer to take the plate from the top, which means it gives you the rule that the last plate that was added to the pile will be taken the first. Okay, in the stack, those operations are called push and pop. On Ethereum virtual machine, stack is used for keeping the arguments of the function calls. Another component is memory. Memory is used for storing the variables that are declared or used inside contract functions. And the storage, which is the permanent memory of the contract. This is something that stays in the database of the blockchain, and it keeps the global variables of the contract. Let's look inside the Solidity smart contract. Here we have a little snippet. It's a small contract. We called it hello XP, just for demonstration purposes, but you can compile it and run it. So once the source code, which is human readable, is written, it is then compiled to the bytecode that is deployed on the blockchain. The fundamental problem with the bytecode of Solidity was that it wasn't human readable, so it can be transformed into opcodes or operational codes, which can be human readable. It's very hard to understand what is written, but it's still possible. It's similar to an assembly language. And there's another file that is compiled, which is called ABI, or Application Binary Interface. It allows external programs, for example, JavaScript, interact with the binary code. It is like a library or like a table of contents of the functions and their parameters that allow programmers interact with the contract from outside the blockchain. Let's look closer at the source code in relation to EVM. As you can see, the first part of the contract is usually the place where people put their constants of variables. For example, in this contract, we have two variables. One is say and another is owner. This is something that will stay in the permanent memory of the blockchain. Therefore, it is storage. The next piece is events. Events notify, for example, the front end or the explorer of the blockchain about something that happened. Modifiers allow adding restrictions. For example, only owner can call the functions that are modified with this modifier. The constructor is a function that initiates the storage variables at the time of the contract deployment. Effectively, it changes the storage again. And then there's the part of the functions where the main functionality or the logic of state alteration is written. As you can see in this function, we're altering one of the storage variables and we're emitting an event. So what are the benefits of Ethereum virtual machine? First of all the chains that using this technology, this protocol, are compatible with each other. It means you can use the same wallets. You can use the same JavaScript libraries such as Web3 or Ethers. They usually follow the same token standards such as ERC 721, ERC 1155, ERC 20, and so on. And of course, a smart contract written in Solidity that is EVM compatible can be reused on multiple EVM compatible chains, which is quite convenient. Written once, you can apply it multiple times. So what are the drawbacks of EVM? Unfortunately, they exist. And the biggest problem is that Solidity is fundamentally unsafe. It allows developers write and compile contracts that have mistakes in them, which leads to backdoors, privilege escalations, and in the worst case scenarios, contracts take over, which already happened multiple times in the industry's history. Some people think that Turing completeness is a benefit, and some people think it's a drawback. For example, in Solidity, its Turing completeness allows entering into loops, causing reentrancy attacks, where one function can be called inside one block before the storage variables are changed, and people can withdraw one amount multiple times, which shouldn't happen. And it already caused multiple occasions of damages to companies and individuals. Also, because EVM chains use the same technology, once a drawback or once a fault is found on one chain, it can be applied to all the chains. And if one chain is hacked in a fundamentally similar way to the others can be hacked as well. And as you remember, the blockchain cannot be stopped. So there isn't much that can be done by the blockchain team in such a case. And another notorious congestion problem occurs on Ethereum and the chains that are growing and approaching the number of transactions that are characteristic for Ethereum. So in the peak hours, the gas prices skyrocket, and the transactions with low gas are not included into blocks for hours and days, and people have to wait for their transaction to be included. And sometimes it can be fatal to the transaction, because if the storage changes, by the time the transaction is included, it cannot change the storage because, for example, it's incompatible with what the transaction is trying to do. And then the transaction will be reverted. So therefore, NFT bridge of XP.network supports multiple non-EVM chains. We already support Elrond, Tron, Tezos, Algorand, and we're in the process of integration of CTO, Solana, Internet Computer, and the Open Network. Since they are non-EVM, let's look closer at what their differences are and what languages and NFT standards they support. So Elrond uses Rust for smart contract language, and its NFT standard, or generally token standard on Elrond, is ESDT, which stands for Elrond Standard for Tokens. Tron uses Solidity, but with some limitations. Some functionality is not possible on Tron. And the NFT standards are TRC 721 and TRC 1155, which in the majority of the cases replicates the standards that are EVM compatible, but we will see why Tron is not completely EVM compatible on the next slide. Tezos uses SmartPy, which is an abstraction of Michelson. Michelson is close to assembler and is hard to write programs with. And the NFT standard is FA2. Algorand uses Teal as its own assembler, and PyTeal as an abstraction in Python for writing smart contracts. And the NFT standard is SA003. CTO, Solana, and Internet Computer, they all use Rust as their smart contract language. But the difference with EVM is you can't reuse the contracts written for one blockchain in other blockchains, because the rest of the protocol, except for the language itself, is very different. They rely on different libraries, different dependencies, and one contract cannot be reused on other chains. Tron uses TypeScript, which is also a good language for smart contracts. NFT standards are SNP 721 for Secret Network, Metaplex for Solana, ICP 721 and EXT for Internet Computer, where EXT is a version of 1155. And Tron supports DIP 62 and DIP 64 smart contracts for NFTs. Wallets and JavaScript libraries used by non-EVM chains are also different. Elrond use Meyer extension and Elrond extension. While JavaScript libraries used here are Elrond network ERGGS, which is Elrond JavaScript library. Tron uses Tron Link Wallet, and the JavaScript libraries that are necessary to interact with it are Tron Web and Tron Station. Tezos uses Beacon and Templar. Beacon is like a Wallet Connect application that allows using multiple Tezos compatible wallets. And Templar is one of the most popular wallets in the Tezos community. Taquito is the JavaScript library, and after slash, you can have its variations and extensions relevant for the wallets and other transactions. The most popular wallet for Algorand is Algo Signer, and the JavaScript library is Algo SDK. Secret Network uses many wallets compatible for the Cosmos ecosystem, for example, Cosmos Station and Kepler. But it has its own JavaScript library, which is called Secret.js. Solana supports Phantom, Trash, and Vuvu wallets, and actually a lot of other wallets too. And the popular JavaScript library for Solana is Solana Web3.js. Internet Computer also has multiple wallets, such as NNS Wallet, Plug Wallet, Stoic Wallet, Earth Wallet, and so on. And again, it has a bunch of libraries that begin with Definity slash, and then you have the extensions of this library. Tron relies on Tron Wallet and Tron Web for the JavaScript library. So how does all this impact bridging? First of all, for every other protocol, we have to write a separate library to support the protocol. We also have to support multiple wallets inside the bridge in order to allow our users sign transactions relevant for those blockchains. All this is handled by the XP.js library, which we called XP.network. It is available on npm.js. And as you can see, it depends on 23 libraries at the moment of writing this video, and 12 dev dependencies. But with every chain we add to it, we depend on more and more libraries. Effectively, it makes it easy for the end user to use the UI of the bridge or to use it from code, as in the example on the right. Thank you for watching, and stay tuned.